problems. We're going to do practice problem number 2. Okay, so practice problem number 2 says give the balanced equation, chemical equation for the reaction that occurs between nitric acid, and it gives you that formula, that's cool, and calcium hydroxide. Okay, so it gives us nitric acid, and that one is easy to remember because it is HNO3, and what's the NO3 called? By itself as an ion. Nitrate. So that's why this is nitric acid, because it has that there, the nitrogen. Okay, so then they want to do a reaction with calcium hydroxide. How do we figure out what calcium hydroxide is? What's a hydroxide ion? Noah, do you remember what a hydroxide ion is?
I'm thinking.
Jaron, do you remember hydroxide? Remember the flashcards?
Oh.
Uh-huh.
Oh, yeah.
Yep, so OH minus. So OH, and on the periodic table, what is the charge of calcium when it becomes an ion? Do you remember which group it's in? I don't have a periodic table, so.
Isn't it like 1? Or no, 2?
It should be in group 2A, I think.
Yeah.
So if it's in group 2A, just notice that if this is a 2 plus and this is a minus, when they combine, remember to write the formula properly. You have to remember, I don't know if you guys learned the crisscross method, but I use the crisscross method, so you circle this and bring it down here, circle this and bring it down here. So that leaves you with Ca, and then OH, and we brought the 2 down here. Because basically we need 2 positives to be balanced out with 2 negatives, and so that's how we know the formula for this. Okay, now we have it all messed up. Just go here. Calcium hydroxide, and we need to make an equation. So what do you think we're going to do? I'll show you a trick, okay? Remember the definition of an acid is it's giving away those protons. It's giving away the positive hydrogen ions. So let's find some. I see one right here that can break away. So if you even want to do this in your head or on your paper, I split these up in my head. Okay, I'm going to split these up too. When this dissolves in water, that's going to form 2 ions. This is going to form 2 ions, a cation and an anion. Okay, one's going to be positive, one's going to be negative. And so I can actually draw this out for you. And we know the charge on this because how do we know the charge on that? I know what charge this is because I can see what it's bonded to. It has to be just a minus, right? It can't be a 2 minus because then we'd have to have 2 hydrogens to balance it out. So now we got these in ions, and we have this guy, and what's my charge on that calcium?
Positive.
Positive what?
2.
Yes. 2 plus, and then that OH minus. Okay, so now these are ions, and you can kind of see this acid here is going to give away this hydrogen, and it's naturally going to want to go here. And what's that going to form? If you stick the H with another H, you have 2 H's and an O, which is called H2O. So it's going to form H2O, and this might be backwards from your book. I think it puts it over here. Okay, and then we have these guys left over. And so how do we bond those together? Remember the cation comes first, so we have to put the calcium first. Calcium, and then we're going to put the nitrate. NO3. Look at the charges though. How are those going to bond? What's my formula going to be over here? Jaron, what do you think I should do? I have a 2 plus here and a minus here, and I'm combining them.
1G, another NO3.
Yeah, I need another nitrate, right? So that means I'm going to make 2 of them here to balance out that charge. Okay? Now I have my equation, but it's not balanced. So now I have to balance my equation. So what should I do? Start with the water. Or this one. Start with the hydrogens.
2HNO3.
This one?
No, the first one.
Yep. So if I put a 2 there, now I have 2 hydrogens. And I have, let's see, 1, 2, 3, 4 hydrogens. So how do I balance it out over here? Let me see. Maybe I made this too complicated. Oh, that's right. Can you balance the hydrogens for me? If I have 4 on this side and 2 on this side,
2 each row.
put a 2 right here. And then that's going to balance out everything else if you want to check my oxygens and the calcium and the nitrates and the nitrogens. So that's your balanced equation now. What was the question? That's it. Find your balanced equation. Okay? So you're going to need to know how to do that because when the problems get more complicated, you have to come up with that balanced equation first before you can use it. All right, let's move on to practice problem number 6. Practice problem number 6 says a chemist has a solution. Oops, I shouldn't have erased that. A chemist has a 12.0 molarity of hydrogen bromide, and would like to use it to make 500.0 milliliters of 3.5 molarity hydrogen bromide. Describe how she should do this. So there's a bunch of numbers there. What are we going to do with them? Sometimes when these problems have a whole bunch of numbers and it's like, where do we even start? I like to draw pictures, like super simple. So I'm going to pretend I have a little flask here of hydrogen bromide. And the problem says this stuff has a 12.0 molarity. And I want to use it to make 500 milliliters of 3.5 molarity hydrogen bromide. So I want to make 500 milliliters. Oops, it's 500.0 of the same stuff with a molarity of 3.5. What do you think we can do with this? That's what I have. Those are the numbers I have to work with. Am I going to use this equation or this equation? What can I do? Joseph, what do you think I could do with this? Which equation could I use?
You could use the moles over liters.
Moles per liters?
Insert 12.0 in for M1.
Yeah, I think I'm going to use the other one because this problem isn't asking for anything with moles. So, you see this? I'm going to plug these numbers into this equation. So my initial molarity is 12.0 molarity. And then I don't have a volume here. And that's going to be equal to, what should I put here?
3.5.
3.5 molarity times what? 500.0 milliliters. Do you want to work that out and get an answer? Basically, this is x. So with algebra, if you divide both sides by 12.0, divide this side by 12.0 molarity, it's going to cancel out the molarity. You get me a number for that? Having a good answer now. This is practice problem 6. What did you guys get? Can somebody tell me an answer?
140.
What'd you get?
140.
140 what?
Milliliters.
Okay, hang on. 1, 2. Okay, the book says 150, except you can't write it like that. So how would I write it? 1.5 times 10 to the second. And then my units is milliliters. Why am I writing it like that? 6. Yeah. So that would be my volume here. my missing volume for here, okay? All right, let's do number 8 now. Okay, number 8 of the practice problem says a chemist reacts 50 milliliters of 4.5 molarity carbonic acid with excess potassium hydroxide. How many grams of potassium carbonate are produced? What's the first step? Before I even use all those numbers, what do I have to do?
Write it out,
Write out what?
the reaction.
Yeah. So we're gonna start with, they give us, what is it called? Carbonic acid, H2CO3. And then it says potassium hydroxide. What do you think that's gonna look like? Without even looking, do you think you can tell me what you think it would look like? Yeah. Potassium hydroxide. What's the charge on that? K?
Positive.
Is it +1? And this is a negative. So that's it. That's what it looks like. Okay, and then we need to figure out what's going to happen. This one's a little bit trickier because we have the 2 hydrogens here. But you know this is going to be your acid because it's going to break up right here. And this is going to break up right here. And so you're going to have these 2 ions, and then this is going to be CO3, 2 minus. And we know it's 2 minus because there's 2 positives here. Okay? So we broke this up, and then we're going to break this guy up here, and we're going to break this guy up here. So now we have it all in ions, and we're going to form something else on the other side. And so where's this hydrogen going to go?
Hydroxide.
Yeah. So Joseph, what does that make? Yes. Are you writing this down? Get out a piece of paper. We're basically doing your homework right now, so you should be writing this down. So I'm going to put H2O, and the book has it in opposite order, but I just do it first, and it's fine. What's left? Noah, what do you think I have left to put
K.
here? Potassium,
CO3 negative.
CO3, 2 minus. Now, I think I messed this up on the last one I'll say it in just a minute, but first let's figure out what this actually looks like. Potassium has a +1 charge, and this has a -2 charge, so then what's my formula going to be here? This has a -2 charge, this has a +1,
So we need 2 potassium.
so I need 2 of these. Now here's where I messed up before. There should be a charge there.
The KOH and the H2O need to be multiplied by 2.
Where's my right? I didn't really want to. Let me just check the answer real quick to make sure.
No, so it'd make 5 off of it.
No, it's fine. There isn't a charge.
KOH
Okay.
and H2O need to be multiplied by 2.
Okay, we need to balance the equation. Did you guys do that already? Joseph, can you write out this equation and try to balance it?
57 on options and
And I'll erase all this stuff.
No, there would be 2 potassium, 2 potassium. OH.
no, there'd be 4. If it's 4, 2, CO3, and you put a 2 here and a 2 here, that becomes 4, and that becomes 2.
But there's still hydrogens over here.
Or,
Oh, I should have left my ions there.
2 potassium,
This
and
is,
the CO3 is -2, and the K is +1. So then it turns into a 2. See that up there?
rebalancing the balance.
Potassium gets balanced.
If only if you put a 2 in front of the KOH.
2 in front of the KOH and 2 in front of the H2O.
Oh,
so if I put a 2 in front of the KOH.
Yeah.
Mhm.
And in front of the H2O as well.
And in front of the H2O. That's actually balanced, right?